Hello there, my name is Peter Drohan. This is my routing and scheduling term project. This is a truck routing dispatch application designed to be used by small business owners to optimally route their trucks. What is the value behind designing something like this? So dispatchers of small businesses or even at a small company need to inform the truckers the optimal routes in little time. Finding optimal routes can take time, especially if your company has limited resources or knowledge. Small businesses can't benefit from applying routing optimizations to their day-to-day deliveries, and I want to provide something that's easy to use, that anyone can use, that's free to use. That way they can get some cost savings. Now, what is this? What am I going to build? The goal of the project is to build an application that provides dispatchers with a tool to route their fleet of trucks efficiently. I'm thinking about something that is a simple web application that anyone can use, enter in their information, and it will calculate the optimal routes for you. Now, how does this work? It's a web application, so it will use Flask. Flask is a super lightweight front-end tool, front-end back-end tool. It's written in Python and it's super easy to use. That way we'll be able to host the information on the web. As people input their information, it'll be sent from their computer to the server, and the server will take a look at their information and call the Google Distance Matrix API. What that's going to do is it's going to send off information to Google, the information that the user put in, and we're going to get back a distance matrix in between these different places. That data is then aggregated into the right location, and it's sent to the Google OR script that I wrote. And this script is going to optimally route each of the different trucks to meet the demand at every single point. This is the academic article review. I looked at a couple different articles, ultimately looking to find what kind of algorithm I should apply in this project. OR tools kept coming up, and it was clear why. OR tools performed adequately optimal to be compared to specialized reinforcement learning algorithms. As you can see here, their path lengths were slightly longer than those of the reinforcement learning algorithm, but if you look at the times, you can see that the times are much, much lower. Google OR is very fast. It was also being compared to specialized recursive dbScan algorithms that optimize through clustering. What these algorithms do is they take all the nodes and they cluster them into smaller groups, and that way there's less less things that can be done. Essentially, it's like pre-organizing the data. And as you can see here, they're a little bit longer in terms of total distance, but their runtimes are much faster. And these applications are more for 200 or 2,000 node applications, whereas the reinforcement learning was 150 to 400. So this is the optimization function for the formulation. This is a formulation of the capacitated multi-vehicle routing problem. The first constraint, as you can see here, guarantees that all customers are visited exactly once. This constraint here, the second constraint, it guarantees that the correct flow of vehicles through the arcs. So if a vehicle arrives at a node, it must leave from that node. The third constraint limits the maximum number of routes to the number of vehicles. So you can't have more routes than you have vehicles. Here and here, the fourth and the fifth ensure the vehicle capacity is not exceeded and eliminates subtours in the solution. Finally, this constraint means that once a node is visited, a node can be visited or not, a 0 or a 1. It's not a continuous variable. Okay, now for the fun stuff. This is the home page. This is where you enter in your information and click solve. The information that was put in here is the same as in my report. The number of trucks being 4, the vehicle capacity being 15, the depot location being the industrial engineering building put here. You can put in any values you want here. Basically, there's error handling, so if something is not found by the Google Maps API, then it'll just return the same page. But essentially, you can type in anything here, and it will essentially search Google to determine whether or not that's an actual address. And it works really well so far. All the checks that I've done ensure that it works just like Google, so nothing to worry about there. This is essentially what the home page looks like. Well, it isn't essentially, it is exactly what the home page is. Okay, now we're into the output, the route optimization results. You can see that the route has been optimized by Google OR's library, and the total load on all routes is 38. That's essentially a sum of all these values here. Okay, the total cost is calculated by the objective and the cost per kilometer. And as you can see here, there's all the different routes. So that we said there was 4 vehicles, that means there's 4 routes. The first vehicle doesn't actually do anything. The second vehicle goes from 3 to 4, so 3 to 4, and then returns back home. Note they all start from the depot, as the problem states. 3 to 4 is Yarmouth to Bedford. And if you add up the sum of the load, it corresponds to the numbers down here. That's just some good verification. So we know from our academic research that Google OR tools is sufficiently optimal and sufficiently fast. But let's look at how efficient it is when dealing with a different number of destinations and a different number and the same number of trucks. The capacity of the trucks went up, so it's not really the limiting factor. The limiting factor is just the number of destinations, which is going to cause the time to go up. And as you can see, as the number of destinations increases, so does the time. But this thing runs really quick. I'll show you in the next slide a video of what it looks like. Okay, let's see if this works. This is a video of the tool being filled out and used and then running. This is the route calculator homepage. Super simple. We're kind of setting the depot location as well as the destinations and the respective demands. The number of trucks is 4, vehicle capacity of 15. The depot location is the industrial engineering building. That's a quick tidbit for you if you didn't already remember that. And then when you click solve vehicle routing problem, runs for a few seconds. Hits the Google Matrix API, and then you can see the results that I already went over. So yeah, that's pretty much the tool. It's really repeatable, really usable. It only takes a couple seconds to set up. So thank you very much for watching my presentation. I hope it was informative and kind of interesting. Bye.